Hello guys, today I'm just making a video on some basic insights on how to solve questions related to the topic SUVAT equations. Now this is a physics concept which could come up for your A-level physics exams, so do watch this whole video. I'm going to be explaining on what SUVAT equations are, what are all the tips that you need in order to solve SUVAT equations, and how to derive the 4 SUVAT equations. And at the end of the video, I'm going to be solving 3 valuable questions so that you guys can understand how to apply SUVAT equations practically after learning all the knowledge of what SUVAT equations are. And time codes will be in the description box below so that you guys can skip to the questions immediately, or if you guys want to go back to the theoretical part of what SUVAT equations are. And if you guys have enjoyed the video, please do like, share, and subscribe to the channel. It really helps a lot. And yeah, let's start with the video. Alright, SUVAT equations. Now the most important part of what SUVAT equations are, they're usually used for objects in constant acceleration. So what I mean by is they're most likely invaluable in any situation where acceleration is constant. So it's part of the chapter of motion along a straight line at constant acceleration. So that's the most theoretical part that you have to know about SUVAT equations and how they're coming about. So the word SUVAT equations just generally means, I'm just going to write it down, SUVAT, okay? SUVAT, sorry guys. Okay, it's going to be called SUVAT. So now the S, now this is the most important part. The S stands for displacement. Now you have to know the value of what displacement is, and it is in meters. The U stands for initial velocity. Now initial velocity is in meters per second. You can just mention it meters per second, or you can create a notation in this form as well. That's alright in this case. And the V stands for final velocity, which is also in meters per second. And then your A part, that is usually the acceleration part, so you can mention that as well. It could be deceleration, but in this case we're just going to leave it as acceleration, and we know that acceleration is in meters per second squared. And T represents time. Now time is in seconds. Do remember that all of these values have to be the same, let's say units, so it has to be meters for displacement, meters per second for both initial and final velocity, acceleration has to be meters per second squared, and time has to be in seconds. Now let's move on to the other most important part of what SUVAT equations are really like, is the part where you have to understand how to derive the equations. Now equation 1, I'm just going to show you guys how to derive the equations using your original formulas. So for the SUVAT equation, equation 1 is going to be starting from, we have to understand the concept that acceleration is the rate of change of velocity. So do remember that point. So from this definition, what I mean by this is that if we have A, which is going to be equivalent to V minus U, V just represents final and U just represents the initial velocity, divided by time, what we can do in order to derive the first SUVAT equation, you can rearrange all of this to make your final velocity the subject of the formula. So what I mean by this is you're going to write V minus U is going to be equivalent to AT. And you're going to rearrange it and make V the subject of the formula. So you get U plus AT. Now this is your first equation, which is derived from the acceleration formula of the rate of change of velocity per unit time. So this is how we get equation 1. Now let's see how you get equation 2. Now equation 2 is pretty interesting because this is where you're using the formula of displacement, which is going to be equivalent to S, so equivalent to velocity times the time taken. Now because the acceleration here is the most important part, because the acceleration is uniform, let's say constant, the average velocity is just the average of the initial and final velocities. So what I mean by this is, let's say the average velocity in this case is going to be equivalent to U plus V divided by, I'm just going to write U as this so it's much easier to identify it, U plus V divided by 2. you're going to use that and you're going to multiply this by the time taken, because that is your average velocity. You're using the formula of displacement is equivalent to average velocity, which is v, times the time. So what we're going to do is going to write u plus v divided by 2, and you're going to multiply it by t. Now, in some specifications, you're going to add s equivalent to u plus v divided by 2 times t. Now, this can be in brackets as well if you guys want, but I'm just going to leave it as it is. Now, this is your second SUVAT equation notation form when dealing with this type of equations. Okay? You're just deriving these equations. Now, let's derive equation 3. Equation 3, since there are 4 SUVAT equations, equation 3 is where you have to combine both these two equations from above, from both equation 1 and equation 2. So we have to combine both this to derive and get equation 3. So we have to also eliminate the final velocity, and a further useful equation is produced in this case. So what you have to do is you have to substitute the value of this of v, that is u plus at, in the place of the final velocity in equation 2. So what I mean by this is we're going to write both formulas down, okay, divided by 2t. And since we know what the final velocity is, we just need to place it in the second, let's say in the second equation. So it's going to become displacement is equivalent to u plus at. Okay, so it's going to be like that, divided by 2 times t. So once you derive this, or let's say once you expand the brackets, you're going to get time as brackets 2u plus at divided by 2, which is going to give you approximately, let's analyze this. So it's going to give you s is going to be equivalent to 2ut plus at squared divided by 2. If you move this on the top, you're going to divide each value by 2 to just simplify it much better. So 2u2 ut divided by 2 plus at squared divided by 2. This is going to simplify to s is equivalent to ut plus half at squared. Now this is your equation 3. All we did is just substitute the value of v into the equation 2, and we just simplified and expanded the brackets to get a new useful equation, which is s is equivalent to ut plus half at squared. So if you remember both these formulas, you can easily derive the third equation. Now let's move on to the fourth and final equation of the SUVAT equations before we move on to the valuable questions that we have to solve. So equation 4. Equation 4 is pretty interesting. The fourth equation is also again obtained by combining equations 1 and 2, but this time we have to eliminate t. Now this can be usually done, let's say, by multiplying both equations in this case. So we have to use equation 1. So equation 1, since we know that it is a is equivalent to v minus u divided by t, we know we have derived it from that side. And since we know the formula for s as well from the second equation, we know that to be as s is equivalent to u plus v divided by 2t. All we need to do now is we have to multiply both of these equations. We have to multiply them together. So what I mean by is, since we do a times s, that could be equivalent to the a's value, which is going to be v minus u divided by t multiplied by whatever the value stored in displacement. So you're going to multiply both these values together divided by 2t to get your fourth SUVAT equation. So once you multiply both this, you're just going to get as is going to be equivalent to, let's say if you multiply these two values correctly, you should be getting, actually you can cut out the t part, so this simplifies to 1. Then you get, let's say v minus u, put in brackets u plus v, divided by 2. 2 you can take on the other side if you multiply it. So you get 2as is equivalent to v minus u plus v. So once you expand the brackets, you should be getting 2as, which is going to be equivalent to vu. Actually, I'm just going to leave it. We're going to expand the brackets. vu plus v square minus u square minus vu. This is going to cancel out each other, so you get 2as is going to be equivalent to v square minus u square. Once you do that, you're going to rearrange this formula again to give you your final equation. We're going to make v square the subject of the formula, which is going to become v square equivalent to u square plus 2as. You're just going to rearrange this formula. If you take it on the other side, it becomes negative. All you need to do is just multiply by -1 to make it all positive. So you get v square is equivalent to u square plus 2as. That's how you derive your fourth SUVAT equation. In this case, you just multiply the equation 1 with equation 2. You're going to get the SUVAT equation for the fourth SUVAT equation. So all variables apart from time, they're all vector quantities, so that means they can either be positive or negative depending on their direction. The key terms to look out is just to mention that whether it starts from rest. If the initial velocity is not mentioned, this means that your initial velocity is equivalent to 0. If it mentions that it starts from rest, it means that the time is equal to 0. Now, if an object is, let's say, falling due to gravity, you can take acceleration from the SUVAT equations equivalent to g, which is gravitational acceleration due to gravity, and you can take it as 9.81 meters per second squared. Now, it doesn't matter which way is positive and negative for any scenario, as long as it is consistent for all vector quantities. For example, let's say if it's moving downwards is considered to be negative. Then for a ball traveling upwards, it must be positive. Then in that way, acceleration would be considered to be negative. Now, SUVAT equations are generally used for motion with constant acceleration. Let's say for an object that's just falling in uniform gravitational field without air resistance. That can also be mentioned out there. So the tips for SUVAT equation solving before we get to the 3 valuable questions is that you have to work out your variables, you have to choose which is the right equation, and you have to convert any units to SI units and then insert those quantities into the equation and then rearrange everything algebraically to determine the answer. Now, sometimes a question may have to be split into 2, and this is where the SUVAT equations will have to be used twice. Alright, so now let's just straight move on to the 3 valuable questions which I've prepared here. So we're going to learn how to apply the SUVAT equations. I'm just going to project the SUVAT equations if any of you guys want to take notes on how to derive these equations. Alright, okay. Question 1. A tile falls from the roof 25 meters high. Calculate the speed when it hits the ground and how long it takes to fall. Take the acceleration due to gravity as 9.81 meters per second squared. So, what I like to do is you can draw maybe a simple diagram of just how a house looks, and you can see a tile falling, and the distance between the roof, let's say, since it falls, is just going to be 25 meters, right? And this is falling, let's say, at 9.81 meters squared. That's the height at which it that's actually the acceleration due to gravity it falls at. So the first step when dealing with this question is to write down all your variables first. So we're going to write the word SUVAT so we understand what we're dealing with in this case. We know that S, which is representing displacement, is going to be 25 meters. We know the initial velocity to be as 0 meters per meter seconds, since the tile is stationary to start with. So that's why we're putting the initial velocity as 0, and the acceleration due to gravity is about 9.81 meters squared. This is due to gravity, and we know that the final velocity is going to be unknown, since that's not known, and the time is also not known. So now what we need to do is, usually we take the upwards as the positive direction, but in this question it's probably easier for us to take the downwards as positive. So we get, let's say, the gravitational acceleration due to gravity as positive 9.81 meters second square. So we're going to take it like that in that notation form. All right. Okay. So now instead of negative 9.1 meters per second, now we have to choose an equation with only one unknown quantity. So among all the SUVAT equations with the values we have for initial velocity, and in order to find out what time is, we have to, in this case, we have to combine two equations. Just like I said in the previous statement, we have to combine two SUVAT equations. So if we analyze this, we have the final velocity, we have the initial velocity as well, we have acceleration, we have the height as well. So we can easily use v squared is equivalent to u squared plus 2as and rearrange this equation to find out what v is. So v is going to be square root of u squared. In this case, is just 0 square plus 2 multiplied by acceleration, which is going to be 9.81 times the distance, which is going to be 25. This, when we square root, when we get all the values, you should be getting approximately, let me just use my calculator here, guys. Just give me a few seconds. Yeah, 0 squared plus 2 times 9.81 times 25. That's going to give you a value of about 22.14. Now we're just going to round this off to 22 meters a second. This is your final velocity. Now we can use another equation which links all of this just to find out how long it takes for it to fall. So we can use this equation, equation 3, which is s is equivalent to ut plus half at squared, since we can find out the time it takes by just rearranging this whole formula since we have all the values given. So you're going to write s is going to be equivalent to ut plus half at squared. All right. So if we rearrange this formula, you're going to just get 25 is equivalent to 0 times t, which is going to become 0 half times acceleration 9.81 times time square. Once you do that, if you rearrange all of this equation, you're going to get 4.905 t squared is going to be equivalent to 25. T is going to be the square root of 25 over 4.905. This is just basic algebra, guys. And you're going to get a value of about 2.3 seconds. This is when you round this off. So this is your time, and we have found out the velocity as well. We calculated the speed when it falls down as well. So you can just mention there that your final velocity is 22 meters per second, and your time is 2.3 seconds. Now this is your answer roughly. We're just going to give it up to 2 significant figures. That's why these are 2 significant figures. Let's move on to the second question. Second question is where a car accelerates steadily from rest at a rate of 4.2 meters per second squared for 6.5 seconds. Calculate the final speed. Now these questions are really, you have to really understand them, how they work. So first thing which I would like to do is to write the word SUVAT. Always, it really helps a lot. So since S represents displacement, that's not needed. So in this case, you don't need to find any height, so we can scratch that out. Your initial velocity, that is interesting. That is going to be 0 meters per second as well. Since the car is accelerating steadily, and the initial velocity would have been 0. Your acceleration, let's say your final velocity is going to be unknown. Your acceleration is most likely given again here. It accelerates steadily at 4.2 meters per second squared. And your time it takes is also given for about 6.5 seconds. So by looking at the values we have using SUVAT, we're going to understand which equation we use among all the SUVAT equations. I do recommend in your exam paper to write down all the SUVAT equations and the way they're derived if there is time, but just directly remembering the formulas or the SUVAT equations would help a lot. So since we know we know the initial velocity, we know the acceleration, and we know the time. We're just going to use equation 1, which is going to be v is going to be equivalent to u plus at. All we need to do is just calculate the final speed, that is the final velocity, and u is initial velocity to be at 0 plus 4.2 times 6.5. Final velocity is going to become about 4.2 times 6.5. It's going to be roughly 27.3 meters per second. We're just going to round this off to two significant figures. This is going to be 27 meters per second. All right, let's move on to the next part. Calculate distance traveled in 6.5 seconds. This time we're going to write SUVAT once again. So you're going to have distance, which is unknown here. Your initial velocity, which is 0 meters per second, as we know. Your final velocity, this time we know that it is 27.3. I'm just taking the correct value that we have found without rounding to any significant number of figures. The acceleration we know is 4.2 from the above question, meters per second. And we know that time is 6.5. So that's a lot of values given to us. So it makes it easier for us to use, actually, if you go back, to use equation 2 in this case to solve, since we know initial and final and the time given, so we can easily find out the height. So that's going to be S is going to be equivalent to U plus V divided by 2 times time. So the height is going to be initial velocity plus final velocity, 27.3, divided by 2 times time, 6.5. So I'm just going to plug these values into the calculator so that you guys can solve them. Once you do that, you're going to get a value of about 88.725 meters. So S, which is displacement, is going to be roughly about 89 meters if you guys calculate this in terms of two significant figures. Now, there's another way, by the way, in order to solve this. You guys can also use this equation, S equals ut plus half at squared. That's also acceptable. You guys will get the same value as 89. You just need to plug in the value of initial velocity as well. In this case, just half the acceleration as well. So in the other equation we're using acceleration, whereas in this we're not using the acceleration. But you do get the same values for displacement to be about 89 meters. Alright, so this is the way to solve the second question. Now let's move on to the final and last question, which is question 3. A ball is thrown vertically upwards with a velocity of about 20 meters per second, and we have to calculate the maximum height that is reached. So what we're going to do is we can always take the upward direction as positive. So we're going to write down what the SUVAT, we're going to write that word down, what the SUVAT equation are. So we know the initial velocity. Okay, let's actually start with we have to find out the maximum height. So that means it's the displacement. So we have to find out that the displacement. So we're going to represent S, which we have to find out as h, as height, okay? S is just going to be considered as the height. The initial velocity is going to be given, since it's given to us with an upwards velocity of 20 meters per second. We're going to take that initial velocity as 20 meters per second. This is because this is the velocity with which the ball leaves the thrower's hand. So that's where it's going to be. And your final velocity is going to be 0 meters per second. Now this is the reason why is because it is at the maximum height is where the final velocity is going to be 0. Acceleration is going to be taken as negative 10 meters per second. You guys can take a negative 9.81. That's also alright, but in this case I'm just going to use negative 10. The minus sign, by the way, is very necessary because the upwards direction has been taken to be positive, so we have to make the acceleration falling due to gravity as negative. Alright, now we have to now use these values and understand which equation do we use. From looking at the equations, we're given the velocities as well, the acceleration. All we need to do is just find the height, and it's easy to use, I think, this formula. Yeah, we can use equation 4 in order to solve it. So that equation 4 is v squared is equivalent to u squared plus 2as. So v square, that's about 0 square, is equivalent to 20 square plus 2 times acceleration as negative 10 times s. If you rearrange this, you're going to get negative 20s plus 20 square, that's going to be 400, is going to be equivalent to 0. Negative 20s is going to be equivalent to negative 400. S, which is displacement, is going to be divided by negative 20. The negatives are going to cancel out each other. 400 divided by 20, that's going to be, your displacement is going to be about 20 meters in this case. So the maximum height you can mention here is that the maximum height that is reached, that's going to be 20 meters. All right, that's maximum height it can be reached. Now the second part of this question is the total time for which the ball is in air, is where we have to assume that g, acceleration due to gravity, is 10 meters per second. We have to find out the total time the ball was in air, so we're going to write the word SUVAT here. So we know what s is. We know that s is equivalent to 0, actually not 20. The reason is because since the ball is back on the ground, right? So that's why we're going to take it as 0. Then your initial velocity, we know, is going to be taken as 20 meters per second, like in the given question, 20 meters per second. Your final velocity is also going to be considered here, but we do not need to consider the final velocity since we have to find out the time for which the ball is in the air. Okay, so we have to take into consideration the acceleration, which is assumed to be as negative 10 meters per second squared. So I'm going to write down acceleration. This is going to be negative 10 meters per second squared. Your time is going to be as time, because this is the time for which the ball was in air. Okay, so that's why we're going to take t as t. So we're just going to leave it like as it is. And we have to check which equation we can use in order to solve this type of question without using a final velocity. And that equation would be equation 3, which does not involve any final velocity. We do have the value of displacement, acceleration, and time we have to find out, and initial velocity we do have, so we can use equation 3 in this case. So if you use equation 3, it's going to be s is going to be equivalent to ut plus half at squared, where displacement is going to be 0, is going to be equivalent to 20t plus half times negative 10 times t squared. So 20t, since this is going to be a half times negative 10, it's going to be 20t minus 5t squared is going to be equivalent to 0. If you rearrange this, you're going to get negative 5t plus 20t is going to be equivalent to 0. Now this is more of a quadratic equation, so what I'm going to do is I'm going to use a calculator in order to solve the quadratic equation. Do check out the other videos on how to solve quadratic equations. Negative 5, 20, you're going to get two values for t in this case, which is going to be t1's value as 4 seconds, or t2's value, which is going to be 0 seconds. Now the required solution that we're going to use for the time for which the ball is in the air is going to be 4 seconds and not this. Since the other solution, t equals 0, it just refers to the fact that the height of the ball was also 0 when it was first projected. So the solution here is going to be time is equivalent to 4 seconds. I'm just going to write that down. These are some valuable questions. Time is equal to 4 seconds. All right, I'm just going to show you the working. And yeah, guys, this seems to be the end of all the questions. If you guys have enjoyed the video, please do like, share, and subscribe to the channel. It really helps a lot. And do comment below on what your thoughts are about this video and whether I should continue solving questions related to past papers or topic questions. And yeah, I think that's it. All right. Bye, guys.